we're excited you're here. This is a talk by the Propagation team. As a team, we have learned a lot about misting. We have a system in use now, so we've learned by doing. And we hope this morning to share some of that with you. Does anybody do misting as a system now? I don't mean hand bottle misting. I mean something beyond that. Does anybody do that now? What do you do now?
Mine's in a raised bed for it, so it's not for cuttings, but it's for like it's a misting system for my veggies.
All right, for irrigation?
Yeah.
Right, okay.
Like the supermarket almost.
Yep, okay. Anybody else?
So I would like to say something that adds to this. I went to a farm to pick up some plugs for the garden, and they said, this is our cutting room. We just take our cuttings and we stick them in the dirt and they get plants. But the key was missing. So
Cool, where was this?
this was near Charlotte, North Carolina Farms.
In a hoop house or out in the open?
No, this was in a big greenhouse type thing, but I've tried to propagate things, without a misting system. The key to them was the misting system.
All right, cool. Anybody else? Anybody hope to do a misting system at home after this class? All right, good. Cool. All right. So misting systems are common. They're commonly used in propagation, but they're also very common for other things. So probably the biggest commercial misting system is recreational misting system. That means people that put it on their back deck or beside their pool to cool off. They're very, very common. You can buy them. They're low pressure systems and easy to install. In fact, I was at the farmer's market last weekend, and one of the tents there, one of the vendors had a misting system around the edge of the tent so that they didn't get so hot. So.
Turn it off.
So misting systems have been used for that purpose a lot. In commercial plant production, they are a necessity. The business they wouldn't be in business if they didn't have misting systems. So there are, as you probably all know, huge buildings with cuttings and misting systems is the name of the game. You either have that system or you're out of business. So we're going to talk about why they work, what they are, why they work, how to build a simple one this morning. That's our goal. So I want to talk, this is part of your handouts. You don't have to write any of this down, but this is how I got started. I just Googled it, literally. And these are 5 different short papers, 3 5-page papers that are really good. They set the tone for what this is, what it isn't. So I highly recommend that you, if you're going to do this, that you do some homework. It's well worth it. YouTube is wonderful for this stuff. I would say most of what I have learned from YouTube. This first guy, Jim Putnam, lives in I think Clayton now. He used to say Raleigh, but I think he says Clayton now. He owned a greenhouse. I think he sold that business. But he literally has 48 YouTubes about backyard propagation. 48. And it's, he knows his stuff. He does it for a living. And is adapting it for the backyard. So he's going from the big end commercial side to small scale backyard. That's where he's coming from. And he knows all the ins and outs of how to do it. They're really good. They're not easy to it's not cataloged well. For example, one year he'll have session 1, it'll be related to propagation, but the next year he'll have session 1 related to the propagation. So if you look for session 1, you'll hit different years and get a little bit confused. But anyway, just hang in there with it, and if you get through it, that's a lot of stuff, and a lot of what I've learned, I learned from him.
Does he go over something a step up from that, say drip, for a backyard, situation?
You know,
Hydrangeas
I have, yeah, that's a,
need water, but they don't do well with squirting at them.
yeah. So the answer is I don't know. He has a lot of YouTubes on plants in general, how to plant them, what to plant, time of year, soil prep, that kind of stuff. I bet you he has stuff on irrigation, but I haven't really researched that. Remember, irrigation and misting are different. You could technically use the same nozzle maybe to do the same thing, but the purpose of irrigation is to get your media, your soil moist, so your plant roots have water, right? The purpose of misting is really different. It's about making the environment cooler. It's about changing the humidity so that the little cutting that you're stuck in the ground has a chance. So it's don't confuse irrigation and misting. Those are really two different concepts. The other guy it's a great story. He married his high school sweetheart. He didn't have a job. He didn't know boo about plants. And the only job he could find was at a nursery. And so he got started and worked his way up. And he said, I want to make a lot of money. Right? Everybody's dream, make a lot of money. And he says, I'm going to do it by propagating and selling plants out of my backyard. So his emphasis is on how do you do this in your own backyard. And he sells a kit that has the timer and the valve and the instructions, the whole thing. I mean, I don't remember the price of it. It's several $100s. It's not inexpensive, but it's the point I'm trying to make is he is doing this for a business out of his backyard. He has no hoop house. He uses shade cloth. But a lot of this stuff I'm going to talk about this morning is not dependent on a hoop house. You can do it in your backyard as long as you have some shade. You cannot do it in full sun. But you can set up a misting system, hook it to your garden hose, and do your thing in your backyard with no hoop house, no fancy whatever. That's what this guy Mike does is he gets the plant started, moves them out from under the mist, hooks them up to a regular irrigation system, and grows them till they're big enough to sell. And he's doing well. So he's worth looking at too. All right, a couple of definitions. There's a difference between fog and mist. I thought this was interesting because I guess I never really thought about it before, but fog is small particles. They're so small that they like to hang in the air. They like to disappear quickly. They move with the wind very easily. They don't settle out on leaves as easily as mist droplets will settle out. They tend to be less than 50 microns in diameter. Lots of them evaporate. But nonetheless, they can be used. So there are commercial buildings that are basically fog houses. Fog is a little harder to generate. It's mostly generated with high pressure air mixed with water. So it's a little bit more complicated to produce fog. Mist is a little bit bigger droplet, 50 to 100. By the way, a human hair is 100 microns. So these are still pretty small things, but it's heavier than fog, so it's slower to evaporate. It's much more likely to fall onto the surface, meaning the leaf or the stem, and wet that surface, and that's what you want. So misting is going to work because that layer that you're depositing on your plant is going to evaporate. And that evaporation cools the plant. We all kind of have an idea that if you have high humidity and mist, the plant isn't losing as much moisture, right? The little cutting with its couple of leaves at the top is not transpiring that moisture as quickly because it's already humid. That's true. That's part of how it works, but it also works by reducing the temperature. And that's probably more important. It's the cooler temperature that you have to have. The first guy I talked about, Jim Putnam, teaches you in his YouTubes how to build your own hoop house in the backyard. He builds one that's maybe this tall. You have to crawl on your hands and knees to get in it. Looks like a doghouse kind of. But he has no ventilation in there. He makes a little window at the top, but there's no ventilation in there. And I'm thinking, like, put that out in the sun or partial sun, it's going to be 110 degrees. Not with the mist system. So he measures his temperature. His temperature's in the 80s, even though it's, you know, in fact, he had the thermometer down at the bottom of the little hoop house, and it was 82 degrees or something. Then he moved the thermometer up to the top of the hoop house, it was 120. So evaporative cooling is really the key to this thing. That's why the cutting is happier.
Is there, when you talk about cooling, is there a range that we should be looking for, like 60 to 80,
Yeah.
something?
Yeah, we're going to get to that in just a second. There is an ideal range that what I read says. I'll get to the slide in a second. I think it's something like 70 to 80 maybe, or something like that. But yes, there is a target. In our team's misting system, we go over that some, not a lot. But I'll show you that again in a minute. Yes, there is a target. So here are the things to remember. Mist is working because it does increase humidity. That's important. Evaporative cooling is really important. I wondered whether the mist actually got into the leaf. I wondered if, you know, you have this leaf sitting there, does the moisture actually get into the leaf and feed the leaf directly? And the answer is it probably doesn't, or it does it minimally. A lot of leaves have a waxy type coating on them on purpose so that the water doesn't get into them as easily to protect them. So we probably are not watering our cuttings directly. That makes sense. The cutting is still on its own in terms of getting moisture up the stem and into the leaf. Even though it doesn't have any roots, it's still doing that. It's not directly getting water from the mist. And you want the mist that you're generating not to overwater your media, your soil. So if you left the mist on all the time, it would get too wet in a hurry. And then when your little tiny roots form, there's no oxygen in the soil, so they drown. That's why the mist has to be intermittent. And there are different ways to make it intermittent that we're going to talk about, but that's really that's where your money is, honestly. That's what, spending money on the timer, on how you're going to make it intermittent is where it gets, you know, a little dicier. So we'll talk about that, but you don't want the mist to make the media, the soil, too wet. So here's the temperature question. So we're balancing things. We got different variables, right? It's not all about one thing, different variables. So the temperature target at 70 to 80 degrees Fahrenheit. You're trying to make it humid. That's a goal. The light environment is important. Now, I don't have a way to measure how many moles. I don't even remember what a mole is. It's a way of measuring light, but there are fancy ways to measure how much light you're actually getting. And you know, light is in photons, and there are instruments that measure how many photons are striking the leaf. But in English, you want some shade. You know, I have a shade cloth on the hoop house that we're using. That's a 50% shade cloth, so it's supposed to cut out 50% of the light. So if you do it in your backyard, you know, you got to be careful with the light. If you get an hour or two of direct sun, you're not going to probably make it. It's better to err on the side of being in the shade. And then the media, you want it moist, so the roots that are going to form are going to have water, but you're aiming for 85, 95%. You're not trying to go better than 95%. If you're dripping all the time, your media is too wet. So when I put my little moisture meter into the setting, it's in the normal range. It's not too dry, it's not too wet. That's where you want it. Make sense?
Yeah.
Questions?
Peter,
Yo,
quick question. So in a homeowner, then, if you have dappled shade where there is sunlight coming through periodically, would a shade cloth would still probably make sense in that situation?
absolutely. So I would err on the side, if you think, well, maybe I don't have too much sun, I would sort of err on the side of, let's put shade cloth on it. And, and Putnam in his YouTube videos talks a lot about that. And shade cloths come in different structures, so it filters out X amount of light. So you can buy different grades of things. Some people get fancy and try to go from the 50% to the 30%, trying to gradually increase the sun. But anyway, you need a shade. So just to beat the band again, misting works because it reduces the air temperature, increases humidity without saturating the soil media. That's your goal. That's your target. All right, here are the components. So piping, everything that I did to put the thing together and learned in the YouTube is about PVC piping. This is very inexpensive, easy to work with stuff. We can play with some of it in a minute if you'd like. This can be directly connected to a hose, garden hose, for example. We use 3/4 inch PVC piping, which carries a lot of flow. You could put 25 mister heads on a 3/4 inch pipe and have plenty of pressure to mist. So we have 4 on our system. So a lot of capacity to increase the size of it. If you use 1/2 inch PVC, you can't run as many mister heads. If you have 1 inch, you can run even more. So you have some variables like that. The simplest thing to think about is 3/4 inch diameter PVC to actually build your little system, and you can connect it to a garden hose. That's the simple way to do it. The nozzle, by nozzle I mean this little guy. These are very inexpensive. The water comes up this way, and it's a small diameter opening, and it hits this little flat looking piece of plastic and disperses. It has less chance of clogging because of mineral content in the water or debris in the water with this design. There are other designs that tend to clog more readily, but this guy is like $3. This is not an expensive item.
Peter,
Yo.
do you know the diameter of the spray?
Yeah, so most people said to put this particular nozzle 3 to 4 feet apart. Putnam put his 30 inches apart, which is what we did in our system based on his advice. So you want dense coverage of the mist. You really want it misty. But if you put them 2 inches apart, you're going to have too much water too fast. So 30 inches is what we use, but probably 3 to 4 feet works. A pressure regulator, I'll mention it, but I don't want to emphasize it. Most water pressure in people's homes is fine for this system. You don't have to worry that it's too much pressure. Most solenoid valves have a pressure reducer already in them nowadays, so you're not probably going to buy a separate pressure reducer. The solenoid valve, I don't want the word solenoid to scare everybody away. It's a weird word, and if you don't hear it much, it sounds like something complicated. It's basically an electric valve. It goes on and off with a little tiny piston that's driven with you flip the current on or you flip the current off. That's all it's doing. And they cost $17. They're not expensive. So the last page of your handout has the information on the nozzle and the valve and the timer. If you said, I want to leave here today and go buy all the things that Peter Gilmer talked about, that's what you can get 2 of them from Amazon and 1 of them from wherever the place is I put down there. The nozzle comes from someplace else. So don't freak out about the solenoid valve. Very common, inexpensive, get them in a big box store. You do have to pay attention to the diameter of the valve, meaning their valve's made for 1/2 inch, their valve's made for 3/4 inch, which is what we use. Their valve's made bigger, so you do have to pay attention to that. The timer is one type of controller. So the controller does what you think it does. It controls the system, turns the system off and on, frequency, duration, all those kind of things. Timer is the easiest way to do it. There's some interesting other ways to do it. This mechanical sensor is sort of cool. It's a piece of metal, thin metal, that sits on a little balance. And they make them shaped like a leaf, although that has nothing to do with anything. But it looks cool. And you put it in your next to your plants. And when the leaf gets moist from the mist, it tips the valve and turns it off. When it dries out, because of evaporation, the leaf raises back up and turns the valve back on. Of course, it doesn't like wind, so it's not used very much, but it was sort of interesting, I thought. So there is a light-operated internal switch that some people use, which means that the system comes on when the daylight first breaks, but it's smart, it's computer controlled basically, and in low light situations in the early part, later part of the day, it doesn't come on as often. And then when you get to the real bright part of the day, it's coming on more often. So there are systems actually controlled by the amount of light that's striking the plants. And then there's even one that works on humidity, on vapor pressure, computer controlled. And a lot of these big operations will use this type of setup. And the comments made sense to me that the people that use them a lot love them, but there's a learning curve. And going that route in your own backyard would not be an easy thing to do. So we're going to come back to this timer idea. That's what we're going to rely on. It's simple, and so the timer, the one we use costs $200. So it is the money of the misting system. The nice thing about this timer is that it's controllable down to the second. So if you buy an inexpensive timer at a big box store, you can maybe get it down to 5 minutes or something, or maybe 1 minute, but you can't fine tune it to seconds. So this timer will turn the system on and turn it off. Ours right now is set at 7 seconds. So every 5 minutes, the mist comes on for 7 seconds and turns off. And it only does this between 8:30 in the morning and 6 o'clock at night. So you're not running it all night long. It's too much water. Anyway, so the timer has the capability of fine-tuning when you're going to deliver your mist. It's electric, it's a plug-in, so you have to have a way to have an outlet near enough by. It tells you how to hook it up to the solenoid, to the valve. That's not a difficult thing to do. But anyway, that's the timer, that's the key to the thing. This is what your handout shows. The first two are the ones that I got from Amazon. This one you get from Grower Solution. That's what I was blanking on as the company that it came from. Any questions about that? I don't want to gloss over it.
Yeah, on the timer, is there a min-max, like, what's the maximum amount
So I'm not sure I'm with you on your question. You could you could set it so that it's on all the time.
Oh, really?
You could set it so it's on only an hour a day. You can do an infinite number of things with it. So if you were using it to control irrigation, you wanted your plants to be irrigated every other day for an hour, it'll easily do that. In fact, most big box store timers that cost $80 or something like that will do that. What this timer will do is allow you to have it come on only for a few seconds and turn off.
And then, but what for cuttings, specifically for cuttings, how, is that the 7 seconds every 5 minutes, is that the recommended frequency?
It's in that ballpark. So different authors talked about different things. One person started with 3 seconds every 3 minutes. Another person started with 5 seconds every 10 minutes. So there's a range of things. And we played with it. We adjusted ours a little bit to hit that sweet spot where you're controlling the temperature, but you're not soaking your soil. I think that's maybe the way to think about it. I mean, one guideline is, like ours, we have a table that our cuttings set on that's perforated, right, so water can drip through. So if you go into, look at the mist system, and there's water dripping out of it, it's almost for sure too wet. So you want the mist running, every 5 minutes it's turning on, or every 7 minutes, and yet there's very little drippage from the tray of cuttings that you have. That's, a simple way of kind of knowing that you're not. What I've started doing is actually putting the moisture probe into the media that the cutting is in to see if I'm too wet or too dry. And that's actually been just spot on with this setting. As the temperature gets cooler in the fall, if we still have stuff under the misting system, we're going to need to back off on the water a little bit. So
temperature thermometer in the probe that tests the media, do you have recommendations for those?
yeah, yes, I'll show you what we did on the temperature side.
Okay.
In Lowe's and Home Depot, you can buy for $15, $20 a sensor that will tell you pH, moisture, light exposure.
I have one of those and I have no idea how to read it.
Yeah, so they're inexpensive. Those things are readily available.
I have to rescue it from its present location.
All right, so here's our misting system. So this is my vegetable garden. I live in northern Durham County, Rougemont. And to the left of this picture is that picture. That's the hoop house. And I don't know if you can tell it or not, but there is a canopy over the top of it. That's the shade cloth.
Wow, impressive.
So this is at the back of it. So this will give you kind of an idea. That's the back of the hoop house. This is a big exhaust fan to ventilate. The sides come up and down automatically to keep it as cool as possible. This is my very large thermometer. Somebody gave me as a gag gift. So these are the tables. This is the perforated top, so the trays sit on top of there. And then what this is meant to show is how we built it. There's a water line that runs from the front of the hoop house all the way to the back, because I have a faucet way in the back of the hoop house. So that's the line that we tapped into. So we put this box into the gravel. We tapped into that water line. And this is showing the first valve. So the valve is going to live underneath this cover that's going to sit on top of that box. This is the PVC. That's what this stuff is. underground and then up. And I put in a vent right here, valve right here, so you can empty it in the winter, so that can't freeze. And then it goes up to make the, this is so this is 3/4 inch PVC all the way down. These are two T couples, and you jump down to 1/2 inch when you go to your mister. So if you use a 3/4 inch, it would be too much flow for the mister head. So you're gonna go down from 3/4 to 1/2 inch. And these connections, I don't know if you work with PVC much or not. It's very simple, but sounds complicated. Most couplings in PVC are glued together. There are no threads. You don't thread something, they're glued together. Once they're glued together, you can't separate them. But it's simple and quick. So you can do all of these connections using this glue. When you get to these guys, I've gone to threads. So this is glued, but this connection is threaded. This is done so that you could change it out. For example, you might want to make it higher, taller. You might decide, I'm growing, where's Jeff? Some of Jeff's mums, and they're 12 feet tall. No. So they're too tall, and we need the mister up higher. So you can unscrew this and screw in a taller one. So this makes it interchangeable. Does that make sense? Makes it easy to change out. And I have examples of this stuff up here if you want to look at it.
Peter,
Hang on 1 second. So this is a point to make. These are paper towels that are stuffed into the top of the PVC before I put the mister head on. And the reason is that one of the things you need to be paranoid about is you don't want any trash in your line. Because trash in your line is going to do what? Clog up your nozzle. You're going to turn the thing on and nothing's going to come out. And that's a bad day. So hey, 1 second. So what you do, the technique is you take these guys out, you turn the system on. There's no nozzle up here, and you just flush it. Then you put your nozzle on. Go.
so, in terms of cutting the PVC, there's a type of saw that, what do you recommend? What did you use?
So I use the saw. The most common thing to use is it looks like a clamp. It looks like a plier almost. It has a cutter in it. And except for large PVC, like 3, 4, 5 inch PVC, you can cut this kind of stuff with that clamp. I just was too lazy to buy the clamp, but you can buy the clamp and you kind of turn it back and forth a little bit and it snaps. So this is the saw. They make, of course, a PVC saw. Looks like a hacksaw. Most people cut it with a cutter.
I will say from my own experience, cutting slightly larger than this PVC, maybe more like 1 inch or it's probably about 1 inch. If I had to buy a tool, I would actually buy the saw instead of the clamp, because you get to a point where like, I don't have that much hand strength, and you're kind of like wailing on it and going back and forth, and you kind of get tired, you kind of get over it, whereas with a saw, like, it feels like you're making progress faster. Like,
Another trick that I used that I thought was helpful is I would take a file after I sawed my cut and use this file to sort of smooth off the edges, because you don't want that debris from the cut. Sandpaper works pretty well for that purpose too. So you do want to be paranoid about trash in the line. That's important. All right, here's the fancy thing. So this is the timer.
Wow.
So this box is this big. And this is waterproof. That's important to know, because the actual working part of this thing is not waterproof. So it comes with this box, but if for some reason it came without the box, you'd have to get something to waterproof it with. And I'm not gonna go through, because I can't remember all the details, but there's a way to use all these little buttons and you can do all your programming. Took about 2 hours for me to get through that, but it's not difficult. Once you get the hang of it, it kind of makes intuitive sense, but when you first start off, you need patience and time. So just as an aside for maybe folks that haven't used this stuff very much, this is electrical conduit, plastic electrical conduit. Electrical conduit comes in metal and plastic, but this is the plastic that looks just like PVC except it's gray. And it's important to remember, if you see something that looks like PVC and it's gray, it's probably not water, it's probably electrical. So you wouldn't want to cut it, right? Make sense? So this is the final product. This is the mister is actually, it's too bad it's not a video, but anyway, that you can see the waters anyway. That's sort of what it looks like. Those are some mums. I wonder where they came from. So I got interested in this evaporative cooling thing. How much difference was it really making? So I bought this inexpensive monitor that has 3 sensors. So this sensor is in the front of the hoop house, right when you walk in the door. This sensor is hanging from another sensor halfway back, and this sensor is all the way back on the misting table itself, under this red cup. It says it's water, what do they say when it's not waterproof? Water resistant. So I was scared to leave it open. And here's what you get. So this little guy's in the hoop house. So this is probe number 1, which is near the front door. It's 92.5 degrees outside, 35% humidity at that moment in time. This is halfway back from the hoop house, 95 degrees. And here's the misting table. 82.4, 57% humidity. So that's kind of proof that you're doing something. I think that's the last slide. Yep. Questions?
Impressive.
Yeah.
Thank you. Thank you.
I have one. The area that you had dug out in your greenhouse where you connected, was that some sort of pressure valve that you put in there or just a regular valve?
It's the solenoid valve that goes in there.
The solenoid? Okay.
So that's what I call the main line, runs from one end of the hoop house to the other, under gravel, underground. It's made of PEX piping, which is probably in most of your homes. Looks like PVC, but it's very flexible, sort of a modern version.
Okay.
So I attached a T-valve to that, so the water comes off at that pressure straight into the solenoid valve on a 3/4 inch PVC line.
So, my husband hates that he could not be here. And one of the questions that he had for me that you just kind of jumped over was the pressure control valve. For some reason, he's concerned about the pressure of the water, but then you had said there was a certain valve that you could use that would control the pressure?
So you can put a pressure reducer, it's called, in line, as part of your piping if you want to. Now, these nozzles are built for standard water pressure, which is usually around 60 psi, 70 psi, something like that. You don't want to jump this down. Like a lot of pressure reducers will drop the pressure down to 25 psi. So like at Cocoa Cinnamon, where you see those real flexible, thin brown or black 1/2 inch piping that goes from one container to another container, that's all at 25 PSI. It wouldn't tolerate 60 or 70 PSI coming out of the tap. Whereas these misters they're fine with that. That's what they're built for. So I don't think you have to put a pressure regulator in it. I've been told that modern solenoid valves usually have a pressure reducer, not down to 25, but probably around 60 or 70 or something like that, built into them. So if somehow you were connecting it to a system that had even bigger pressure head, you wouldn't mess it up.
Thank you.
So remember for your husband or remember that low pressure irrigation system, drip systems, mist that you buy at Home Depot, Rainbird systems for watering things, they're all low pressure systems. They're running around 25 PSI. So you gotta have a pressure reducer for that. This is different. This is in a big old stiff pipe that can handle the higher pressure. So you actually wanna maintain that.
So in my house, there is a difference between the water pressure in the backyard faucet and the front yard faucet. Now, I have complained about this, but everybody's real reluctant to accommodate me by lowering the pressure. So when I would water the front yard, I would have hoses pop off. And,
Wow.
so I did purchase a pressure regulator, and I haven't quite, I had a little problem this summer, but anyway, to lower that pressure so I could use a regular hose.
Interesting.
But you think I don't know what the pressure is in the front yard versus backyard. So is there any way to tell?
Yes. So you can purchase a valve that you screw onto your faucet. I don't know the cost because haven't bought one recently, but we use one at Cocoa Cinnamon to figure that out. So it looks like it has a little dial on one end. It's copper. It's about this long. You literally screw it into your faucet, turn your faucet on, and the needle will jump to whatever your water pressure is at that moment in time. So you can measure that directly.
For some of this stuff, if you wanna see like an approximation of what it is, we can also look right out here. Because when we hook up these cisterns to irrigation, right, we have a box out there that has a valve in it, right, that has a similar valve that's gonna be running on a timer. We have a pressure valve, and you can literally watch the pump turn on because you can see that pressure shoot up, right? And so it's not the same as kind of the nuance of what Peter has in his setup, but if you just want to see like vaguely what does this look like, right, we can take a look out here at some of the setup and how all of this is working.
Peter, one of the challenges you have is you have a well system versus a homeowner that we have typically higher water pressure. What did you do to compensate for that?
So I did measure the water pressure. I do have a well, you're correct. I measured, my water pressure is 72 or something like that. If I had city water and my water pressure was 120, I probably would get a pressure regulator because the valve is probably not set for that. That's a good point. The city pressure might be another variable in there. If the solenoid valve really has a pressure reducer in it, you're probably home free without adding it. Jim Putnam's YouTube video about the valve says the newer valves have pressure regulators in them. When I look at the package that mine came in, it doesn't say the word pressure regulator anywhere, so I can't confirm that 100%. So we do have some challenges with the misting system that I want to briefly talk about before we end. One of them is that we have hard water in northern Durham County, so we have lots of minerals in the water. And we get, I'm calling it salt deposits. I don't mean sodium chloride, I mean salt of some type, maybe a calcium, like calcium sulfate, for example. But we get deposits. You can see these, they're you know, like when you first go into the hoop house in the morning, it's dry because it's been off all night. You can see this white buildup on the black tabletop that the things are setting on. And you can even see the deposits on the leaves. So it's, if you leave the little cutting under our misting system for a couple of months, it's gonna have a layer of deposit on it. Now, how much harm that's doing, I don't know. I scraped it off the leaf when I pot the plants up, but that is a concern. If you get too wet, you can get in trouble with algae. Algae can be a real problem. The commercial growers really focus on not letting algae get started because it's so hard to stop it once it gets going. So those are some of the challenges to be thinking about. You know, typically a cutting should stay in the misting system 2 to 3 weeks is what my reading has said. Now we left some of our cuttings, some of the semi-hardwood cuttings in there for a couple months because they weren't rooted up enough. We did the pull test and it just is not ready to pot up. And the trade-off with that is that you get more of this deposit on the leaves. I don't know how harmful it is, but it's there. In city water, I don't know what the chlorine does. If you leave it under the mist long enough, does that harm anything? That's something to learn. I don't know the answer to that. But that's something to think about.
If I had an area, let's say 4 by 8 or 5 by 10 or whatever, is there a formula to determine how many mists that you would need for an area?
Yeah, so you want, I said 30 inches apart, so if you think about putting one in the middle of your area and measure out 30 inches, you've covered that 30 inches. Actually, it's probably better to think about it as 15 inches. So that the next one, 30 inches from the first one, you want it to overlap a little bit. So if you had something like as long as this table, it would just take 2. Put one here and one here, and it would cover all of that table. If you did both tables together, you'd probably have 2 here and 2 here, and you'd have it. So 30 inches apart, and you just have to figure out how many of those you would need for your length. And then the width is 30 inches also. It actually covers more than that 30 inches, but you want it really covered. Does that make sense? On the very fringes, you don't get quite as much mist.
Okay.
Do you have any idea how much water you use?
Great question. The answer is no, I don't. Some of the stuff I read calculated that, and it's a very small amount of water. It's amazing. It was, I don't remember the number, but it was like in the single digits gallons per hour.
It was,
Because the mist is on such a short period of time. So I don't have a hard number for you, but it's surprisingly low.
I read somewhere it's for 1 gallon per hour per mist. 1 gallon per hour per mist.
Okay. For this purpose or for irrigation? For this purpose?
For
For this purpose? Okay.
1 gallon per hour, yeah, per mist.
All right. So I have 4 mister heads, so that would be 4 gallons an hour. That might be right. Yeah.
Like one toilet flush.
Yeah, exactly. It's surprisingly little. So if you want to come look at some of the toys, they're just examples. Maybe you're tired of PVC or don't ever want to see PVC. basically build a mock-up, so you put your system together with no glue to start with, so you figure out where all the mistakes are, do all your measuring. And then when you take it apart, there are 2 steps to gluing. There's a solvent that goes on first that removes a protective film that's on the PVC. It's important to put the solvent on first so that the glue, which is the second step, can bond to the actual plastic. Does that make sense?
Yes.
So there's they're color coded. There's a bluish solvent that goes first, and then there's this purpley glue that goes second. And you do both sides. So if you're going to glue this to this, you would do the inside of this with the solvent, the outside of this with the solvent, and then put the glue, and then the glue, and you stick them together. You have a few minutes. It's not, you don't have to rush it. So in other words, if it takes you a few minutes to get this in, and you got 12 of these to do, you can take your time, get them all done. But once you put them together, it bonds quickly and solidly, so it's done. And if you mess up and you have the wrong direction or something like that, you have to cut the PVC and start over. You can't take it apart.